And since it's my first time on stage, I want to test this thing where it's a call and response. So I will say it's about, and I want you, everybody here, to shout time. Got it? Then, it's about good. And it's the observations of the ambiguity about time in software engineering. So, who am I? I am Petter Salminen. I'm working at Magello, which is a consultant firm here in Stockholm. I'm a Linux and programming enthusiast, many different languages, not only Python. I'm an experienced and curious developer, and somebody who has opinions about time. So what's the big deal? Well, in computer systems, we often want to know when something happens. It's a point in time that you usually can then compare to something, like yesterday was before today, and tomorrow is after today. So we can order time, points in time, with something, and we can use them in a computer system. And we also want to know what it was over here, maybe what it was over there, because sometimes if somebody just says 12 o'clock New York, I'm like, I have no idea when that is. And sometimes we want to see the difference between two different points in time. So duration. And with the duration, sometimes you add something like something is slow or something is fast, and that's purely subjective, right? And the main crux of this whole thing is humans. Humans are subjective and have opinions. Humans assume a lot of things. And people are stupid, me included. So, here are some common assumptions that most people, if I just poll on the streets, they would believe, yeah, that's true, of course. There's 24 hours in a day. A minute is always 60 seconds long. Time can never move backwards. Leap year is every 4th year. There is 7 days in a week. And there is 52 weeks in a year or something. The weeks even starts on a Monday. Or that your program will never run in another time zone, and that programming time is easy. Let's start with serialization, which is one of the biggest things we have when computers and humans interact. So typically a computer will have a datetime by having a number. It doesn't have strings, it's only working with a number, like many other things in a binary computer. So here is the time right now. And it doesn't say me much as a human, because this is the Unix timestamp, which is the amount of non-leap seconds since January 1st, 1970. And it's not very human readable. Like I said, if you give me a random number of 1,732 million, I have no idea what that means. But the computer sure does. So for that, we actually want to represent things as time, as text. So right here, we have another one where I'm not good enough for PM and AM stuff, but this is the regular date serialization, which it says is the first day, November 14th. Or we can use the RFC 5322, which is the standard for email. So this is used in every email to determine when the thing was sent and such in the headers. We also have the 3339, and I've specified it for seconds, to just show the internet standard of time and how it's serialized. And some of you have probably seen the next one, which usually is the thing that people have heard, which is ISO 8601, which is almost my favorite standard. And when it comes to time on the internet, then it's a good thing to actually have some user experience for it. So here I took a screenshot a long time ago, as you maybe can see, that it said that something had happened in the Linux repositories X hours ago, so I can have something relational to when I'm actually viewing it. That's a good practice. And it's also good practice to mouse over action the actual time it is, because otherwise you wouldn't know that this screenshot is 2 years old right now. Or if you're actually having problems with site and so on, and using like a computer to browse the web, and you maybe can't even see your wall clock, you need to query what time is in order to know it, then it's good as well. And then we have something called localization. So different countries and different like cultures will have their own standards and rules. And famously on the internet, we have something like this. This is the 12th of November. But this is the 11th of December. And as you can see, there's not much difference. There's only a difference in who's reading it. So that's not a good thing. And from one of my favorite comics, XQCD, they have this public service announcements. Only write year, month, day. And that's it for the internet. You maybe like cats, but I wouldn't like that cat. Oh no. Breaking news, everybody. It has been 0 days since I've seen a date time in an OpenAPI that doesn't follow the standard. So what do I mean? If you have an OpenAPI, formerly known as Swagger, and you use the formatting for the string as datetime, then that is defined as RFC 3339, and it means that part over there is mandatory, and you must use it. And what does it mean? Well, either you have the Z, and that's the Zool, which only means UTC 0, and otherwise you can type anything you want there. And if it's missing, you're probably a Java developer, so please don't do that to me. I've seen it so many times, and it does create bugs. And here is from at least the 3.0 definition. You can see that it says diet time, and it says exactly the RFC 3339 and what it should be. And of course, people read the implementation details and documentation of everything they use. So what is this? Zulu, I was saying, and offset and time zones. Well, Zulu is just, or the Z, it's just 0. An offset, it can be any kind of number, which is just a relation to the UTC. So if I have +1 hour, then it's +1 hour from the UTC. And a time zone is something a little bit different, actually, because that has rules. Like Europe-Stockholm is a time zone. What does UTC even stand for? Well, there was 2 great countries, French and the English, and they were like both really good at time and ISO standards and SI units. But they couldn't really find out what they would call this thing. So in English it's called Coordinated Universal Time, the English said. This is what we want. But the French, and I won't be trying French because I don't want to offend anyone, they wanted TUC instead. So they agreed to disagree and take something that wouldn't match any of them. And that's why UTC was agreed upon. And UTC is the outmost standard for civil time. Civil time is what we use as humans. We're civil communication or whatever to say. Civil time. And when you're talking about time zones, Zool, and offsets, it's always in UTC. What are time zones? Well, some people just think, just take the whole map and splice it up, and there you have got them. But no. Like one of my favorite lines is this one here, the 6. And as you see, it starts at 6, goes to 7, goes to 8. Then we have Nepal, which is 5 hours 45 minutes, and 5 hours 30 minutes for India. And then we come to 6 again. But the only actual islands that are in it is they're an offshoot. So yeah. So you can't think of it as exactly where they are. And this snapshot is it's not always exactly that, because some things make it change, like daylight saving. So daylight savings, it is the practice to basically change your time zone depending on if it's summer or winter, in an effort to save energy consumption, which was invented during the World Wars, because it was very much like people go home and they burn coal or gas or whatever at home to keep the lights on. If they just go to sleep instead, we save energy. So here is a map. Around the equator, there's very smart people. They're the ones with the dark grays. They have never used this. The light gray are countries that have used it but stopped. Very good on you. Then we have like some kind of stupid pact here, which still use it in the north. And very few in the bottom that are using it during the other time, because they have summer during our winter and so on. And they don't always apply at the same time. So Europe and England and North America, we don't start the saving time at the same time. So it could be a week before or after or whatever. And if I remember correctly, usually there's some swear words in the database that says, oh no, the English Parliament has decided that it's on Sunday. And we need to synchronize everybody's computers by Sunday. Thank you. So this is only also for November 2022, because this thing also changes. As you can see, we have Paraguay, or no, I don't know sorry, I don't know the names. Uruguay, yeah, and then we have Egypt that joined it recently. And then we have Arizona, which is a bit special. We have parts that doesn't use it, and parts that does use it, and parts inside of the part that does use it that doesn't use it, and parts inside of the part that does use it inside of the part that doesn't use it that does use it again. And this is something your computers need to know about. And that's why we have the TZ database. The TZ database is usually included in your OS, programming language, or third-party libraries. And in order to keep the information correct, these things need to be up to date, because otherwise there's no magic updating them. And if you're using Python, you might want to look at TZ data. It's one of the things that you can use, but of course it's the final fallback, I think it was. So if your OS is not up to date and it gets it from there, then maybe it doesn't work, so it's a bag of worms in itself. And the TZ database is just a list to try to keep these rules up to date and just have it there so you can calculate in advance and backwards in time what should be correct. And if it's not up to date, you will find bugs. So here is Stockholm, and we can see that we had a time zone before 1879, which was 12 minutes, 12 seconds, and 1 hour ahead of UTC. So if you're actually having an historical application that says the battle blah blah blah, or Kung Vasa's ship sank at, to know the exact time, you need to apply the standoff. And then we had the Swedish time, then we had, or joined the Europe, so we had the UTC +1 exactly. Then there was war, and Sweden changed for 1 year, thought, this is bad. But then when we joined Europe, we needed to use the time saving again. And the biggest problem is when people think, writing code, that's just easy. I just add some numbers and just do some plus, and everything will just work out fine. I've seen it too many times when people don't use the TZ database or the standard tools to try to do stuff. They try to do it themselves, and it bugs. Or you're not specific enough when, for example, building an API. When does it stop and when does it start? Well, it only says a day. Which day? Is it the American day? Is it Swedish day? I don't know. And is this included or excluded? Well, I'm a human, so I have to assume things. And whatever I assume, it's 100% wrong. So you need to be more specific. So if you have something like a from and to date, add the time zone so we know which country you're in. And that's it for it. Otherwise, the computer will not do what you want it to do. And you will create some kinds of off by 1 errors usually, where, why is this date an hour too early? Why do I get this event saying it starts now, but it started an hour ago? Oops. Especially in an international community, it's hard. And we come into synchronization. So if we have a timestamp from a computer, how do we know when it actually was if the computer just says something, right? So the computers need to be synchronized. Otherwise, something from a computer doesn't make sense. If my computer is off and says it's 1990, it doesn't mean it's 1990 today. And thus, you need some way to make sure that they're at least somewhat up to date. And that's why we have NTP, which is the Network Time Protocol, and they love atomic clocks. So it's kind of simple. It's just a hierarchical network of, you have the clocks, you have some master servers that vote together what the time should be, and then you push it down into servers, and then our cell phones and computers will ask these NTP servers, what is the time? They will ping pong back together, see what the delay is, and then they will get the synchronous time that is pretty much up to snuff. And I wrote something, but I'm not reading. So what are atomic clocks? Well, it's just a clock that measures the frequency of atoms. So did you know that a second is an SI unit of time? Of course. And did you know that it's defined by the cesium-133 atom at rest at 0 Kelvin? When it has done its little dance a lot of times, that's when a second has happened, and not the other way around. It's not that we think this happens this amount of times in a second. It's defined that when this does this thing, a second has passed. And it's not in sync with our planet. It's not in sync with the sun. It doesn't care if it's 24 hours a day or whatever it is. It will do its little jig, and then it has happened a second. And like I said, it's not it doesn't care about those. And because it's a little bit off, we sometimes add leap seconds, which I will not go into, but these are in the TZ database. So you update. And these disruptions of either the normal time zones or these leap seconds have created bugs in, for example, flight systems, where the whole thing crashes because suddenly there's 60 seconds or 61 seconds in a minute, and they're like, what? What happened? And the whole code crashes. So what to use, basically? Well, I said the UTC many times. It's great for civil time. That's why we use it. There's something called UT1. I won't go too much into it, but it's when we look at the stars and the sun and determine what the time is. That's what UT1 is. Because you look at the sun, if it's halfway, then it's midday. They say 12. But it's not synchronized with this UTC always. And we have the International Atomic Time, which is just a counter from, it's like the Unix time, but with these clocks instead, these atomic clocks. And UTC is, I think, currently, when I wrote this slide 2 years ago, 37 seconds behind the amount of atomic times. Nice that we have something that we can trust. Well, if I try to explain it simply, time is relative to your frame of reference, and time moves differently in another frame of reference, or can at least. So when it comes to time, the universe is just giving us the middle finger. And on Earth, sometimes we think, well, we're just on Earth, it doesn't matter really. But soon we will have, and we already have, a thing in space, and then it's something else. Like, just to exemplify how it works. If we have 2 of these atomic clocks, they will stay in sync forever if I hold them in my hands. But I will take one of them and send it to the stars. Just a little vacation, see the moon and come back. And when it comes back to Earth, my 2 clocks are no longer in sync. But is there actually something practical where it makes a difference? Right now, today? Yes. You have probably heard of GPS. How does a GPS work? Well, the GPS satellites, they will tell you the time and their position. And when I have 4 of these satellites telling the time and the positions, I can do calculations like, it's so far away and so far away, and I can suddenly calculate where I'm on Earth. And if the clock is wrong by 1 nanosecond, then I will be off by 30 centimeters on a map. That's nothing, I guess. And each day, due to relativity, they would be, or they actually are, going to be 10 kilometers incorrect if I just had the normal clocks on them because of relativity. Or the 10 kilometers is what I calculate because they have 38 microseconds every day that they drift off the time we have here. And it's going a bit slower because they're in motion, but they're going a bit faster because they have less gravity upon them. And that's the relativity part. And some people, if we send, like these are just some computers in space, who cares? Well, we have the ISS, and luckily it's not that much of a thing because they rotate very quickly and at a low orbit. So they only have minus 0.25 microseconds a day. But if I live there 100 years, I will save myself a second, I guess. It's not much, but it's something. Anyhow, let's get back to Earth. And let's do some top tips for programmers that I learned in the field. And that's why we're here at PyCon, right? And not listen to me. So, when you're communicating about date times and using strings, at least make sure to have the offset. ISO 8601 is super nice and everybody talks about it, but it doesn't require the offset. That's why I've been talking about this RFC 3339 all the time, because it's basically a sub or an extension of ISO 8601, a bit stricter, and officially enforces the offset. And that's what we want in the computer systems. So, do this, not this. And always try to use, if you use datetime now, try to use TZ and put in your zone. If you don't care about zone, put UTC, I don't care. But do that, that's super good. Don't use these, especially not this one. Here it says datetime.useless time constructor now, and that's what it stands for. And if you want something useless and you want it now, there's nothing more useless than that one, so get it. But if you don't want something useless, use this. And you know that because you have read the manual, right? It's even deprecated since 3.12, right? Never use it. And here's just to exemplify what's happening, right? So I have just used this now and this useless one and the two good ones, and I get what the time is here. And then I add a day. Very good. It's like adding a day. It's no problem. And then I calculate how long something has taken. So for these two first ones, it has been 25 hours. For the real UTC one, it has only been 24 hours for the day. And in Sweden, it has been 24 hours. But it makes sense in Sweden because in Sweden, we had DST right there. But if my computer and the locale on the OS is not set to Stockholm, then these two do something else. And as you can see, we don't want code to work differently because I have something external, not in my program, set to something. That's why it's important to set the time zone. And when you write tests, I love using freezegun. So freezegun, you can set the time to something. And if somebody somewhere in the code, not even your library, some other code, does now, then it will get that time you told it to get instead. So then you can actually test things. I also like to use PyTest with fixtures. So here's just an example with using the freezer fixture. And I just move the time and say, is it leap year? Yes. And is it leap year? No. Is it leap year? Yes. So I can test these things out without waiting for the bug to happen. So again, time zone information is very important. Make sure to have it. Don't waste your time by not having it. And be specific about when. Don't let humans assume things. And finally, I want to thank you all for letting me occupy a bit of your precious time. Thank you.
Thank you, Peter. That was a very interesting talk. Any questions?
Hi, and thank you for the presentation. So I'm a big advocate for just getting rid of time zones, and that's some international resistance somehow. You seem like a man that have opinions about time, so I want to know, are you an ally in this fight? Or?
Well, you want to have the same clock all around Earth. Is that
Yeah,
what you're
exactly.
saying? And people will then no longer be able to use midday and midnight as two concepts about what it is. It will be moving all around the globe.
Yeah, I mean, it's also a construct, so anyway. So.
And sure, we could have that, but that's very hard for the humans in place. If I am used to having midday at 3 o'clock, and then I go to Sweden, when is midday?
Whatever you want.
Whenever I want. No, in Sweden it would be at 4 o'clock, I guess. But for somebody who's traveling somewhere, they would know nothing when they once get there. So if you go there and read, oh, at the timetable it says the train is going at o'clock, when is that? Is it on the morning, on the night? So a global one would be a bit confusing as well, wouldn't it?
Not for computers.
Yeah, exactly. And that's why we have civil times. But
Right.
I do understand and agree, for computers we should have one thing, and that's not having at least DSTs.
Yeah, I agree. Thank you.
Any more questions?
Okay, he's running that way, you're running up there. So who's first? From there.
I guess I was faster on the draw. Speaking of DSTs, I'm assuming you're aware of the EU initiative to remove.
Yes.
What are your thoughts on letting each country decide what time it is?
Yeah. So they will choose probably something called summertime, because people love summer. But summertime, Sommerzeit, was invented by some guys during the Second World War in German to make it sound better in order to get people to start changing the clock, because before that they didn't have it. So I don't like people being able to choose, like they sent to the Swedish government every year. Somebody's like, we should let it stay on summertime all time around because everybody loves summer. Yeah, but then if somebody else chooses wintertime because they're smarter than us, then we will start having the same kind of problem in the whole EU, where we have to check the TZ database and what do they use now, and have they moved over or not? So at least in Europe, I guess it's good that we synchronize together, but I would prefer everybody to not choose the thing called summertime. That's my long-winded answer. Thanks for the question.
Could you just let me know why was that UTC now or now UTC so bad?
Yeah. So it's called UTC because it's useless, right? And it will suck from your computer your TZ. So it's not UTC rules. So here, for example, I am getting the time, and sure, it looks like it's in UTC, but then I let a day go by, and a day is suddenly 25 hours long. But the day was never 25 hours long in UTC, because it doesn't have the DST. But if my computer is in the cloud or somewhere else, suddenly it will work fine. And we don't want programs to work randomly good, depending on your computer. We want programs to be deterministic because we wrote the code and we wrote the tests. And like I said, it's not only me that says it's bad, it's the whole Python thing here. This is the official documentation. And you see this red box has been there for a long time. And since 3.12, it's deprecated for removal. So if you will keep it and you will just keep on updating your system, suddenly your Python will throw runtime exceptions because it doesn't exist anymore.
Thanks.
I think he had a hand, so if you go there as well. So we start with you.
Yeah, so a couple of things. So the first one, you were right, it was Paraguay, it was not Uruguay. I'm really bad at geography.
Me too.
The other thing is that I come from one of the problematic countries there, the long one.
Huh?
And there is no, it's Chile.
Chile, oh yeah.
Now you are bad in geography as well. And there is no concept there of UTC, but we use GMT for everything.
Hmm?
What are your opinions on that? And I have a follow-up question
Yeah.
on that thing.
So I would have put that on the first slide where it's common misconceptions. GMT is the time zone they use in what?
Astronomical observation time, right?
Yeah. No, yeah, exactly. It's the time zone they use in the garden in London, which is the Greenwich Garden. And they had, long time ago, a clock tower that had a ball that was bouncing, so you could see what time synchronization you should have out on your boats. And then it just got stuck there. But it's very different. GMT and UTC are not the same.
And the follow-up question with that, at this conference, how do you do when you need to communicate one specific time to people in other sides of the world? Which resource, website, whatever you use? Because sometimes I want to set a meeting with people in different continents, and I said 1 p.m. UTC, and they have no idea what UTC means, and they don't know where. So what do you personally use to communicate the proper time?
What I personally use is either Outlook or Google Maps, and I send them an invitation. And there it will be the correct time for me and for anybody who reads it. So they will see it in their local time, because when you create an event, you will set it to a time zone, and then in the back end it will do something with the front end and show the correct time in your local time. And if you're abroad in another local time that you're not used to, then it's hard again.
Thank
And
you.
we had a question from over here somewhere?
Yeah.
There.
Thanks for interesting presentation. So by now, all our code is handling daylight saving. And if we now switch, like in Europe, if we decide not to use daylight saving any longer, what would happen and how would we do that switch? Is it enough to update this database you mentioned, or what would we do?
So if you're not calculating stuff by yourself with the daylight savings, then everything will work if you keep updated to the TZ database, which is one of the three. It can be in the OS, in Python itself, like some Python sub revisions are just updating the TZ database. And there's the third-party TZ data that exists in PyPy that you can also use. So if you will keep your program and running environment and stuff up to date, which you should because computer security, you know, that it should work out fine, as long as you haven't written something yourself. So if you're going to use something, don't write it yourself, and use the datetime now with the TZ for whatever, and it will do what you think it does. And if you don't know, use freeze gun and do tests for the future.
Thanks.
Yeah. Thank you.